Hi, this is Ron Cipcic. In this segment, we're going to take a look at the monopoly model, and in the end, we'll be graphing the monopoly model and learning how to determine where the monopolist maximizes profits. We begin the analysis by looking at a couple tables that will help us understand the relationship between prices over here, and marginal revenue. And I want to take a few minutes before I draw the monopoly model to explain the relationship between price and marginal revenue. Now, we're assuming here that the firm is a price maker. If this is a monopoly, there's only one firm in the market, and that firm has almost absolute price making ability, that is, unless the government steps in and regulates rates. Many monopolies are actually created by the government, and the government legally takes the place of regulating the rates of the provider. For instance, a utility company. The government gives the utility company the exclusive right to produce electricity in a particular area, and then sets up a public service commission, like in Michigan, where I'm in Michigan, so I'm used to the Public Service Commission in Michigan. And this Public Service Commission actually regulates the rates of utilities. Okay, so this firm, the moral of the story is this firm has price making ability, and the government may try to temper that a little bit, but nevertheless this firm has control over price. Notice this demand curve data here shows that as the price goes down, the firm can what? Sell more. As the firm raises the price, the firm is going to sell less. So the firm is actually manipulating the price, whereas in a purely competitive setting, the firm has no control over the price. The price is actually determined by millions of sellers and millions of buyers interacting independently in a market setting, and the price becomes something that is beyond the control of any one producer. Okay, now what we have here is a simple demand curve. As the price goes down by 1, the quantity goes up by 1. So this is demand curve data. The total revenue column is simply price times quantity. So if we take the price, multiply it by the quantity, we get the total revenue. What we see is that as price drops, total revenue increases, but increases at what? A decreasing rate. As price continues to drop, total revenue peaks, and then it begins to decrease. So it's very interesting that changes in price decreases in price first increase total revenue, then as we go further don't affect revenue, and then as we go even further, even lower, actually decrease total revenue. And this has to do with what is called price elasticity of demand, and that's really not the purpose of this lesson to look at that question. But if you want to understand the relationship between revenue and price, you want to look at what is called price elasticity of demand. Now, our interest in putting this demand relation up is to look at marginal revenue. What is marginal revenue? Marginal revenue is the change in total revenue over the change in Q. So every time we add a unit, we're interested in how does revenue change. Notice Q is changing here by 1 every time. Every time we change Q, we add 1, but notice that total revenue is not changing by the same amount. We go from 0 units to 1 unit, our revenue jumps by 6. We go from 1 unit to 2 units, our revenue jumps by 4. So in this case, notice Q is always changing by 1, so we could really say that marginal revenue is simply the change in total revenue. After all, the change in Q is always 1. Anything divided by 1 is itself. Okay, so notice as we go from 0 to 1, marginal revenue is 6. We go from 1 to 2, marginal revenue is 4. And what we see immediately is that marginal revenue is declining. And this is a principle. Whenever the demand curve is downward sloping, whenever the firm has to lower its price to sell more, its marginal revenue will be a declining function. It'll decrease as we produce more. Notice also that it's decreasing faster. Where the price is only decreasing at an interval of $1, marginal revenue is decreasing at an interval of $2. Later on, when we plot the marginal revenue data against the price data, you'll see that the marginal revenue curve is steeper than the demand curve because of this. Now, I'd like to explain how we got this calculation, marginal revenue, in greater detail. Plus, I'd also like to explain why marginal revenue can actually be zero. That's a very interesting idea, that you could actually produce a unit and add no revenue to your output rate. Whereas you're selling it for a price. You're selling the fourth unit. You're selling, look at this, you're selling the fourth unit for $3, but your marginal revenue is zero. Look at the next one. You're selling the fifth unit for $2, and yet the marginal revenue on the fifth unit is minus $2. What is going on? Well, let's explain that. Let's take a look at that. And I've set a little table up here on the right to help us understand this a little better. Look, if we want to sell one unit only, what's the price going to be? The price is going to be 6. So these are units up here. These are units. And then I put prices in the table. So if we want to sell one unit, we charge a price of 6. So the marginal revenue then on the first unit will be 6. If we sell one unit for 6, the marginal revenue on the first unit will be 6. However, if we want to sell 2 units, what does the law of demand say? It says we have to lower the price. So if we're going to sell them for the same price to different buyers, in other words, we're not going to price discriminate. Now, let me just say something quickly here about price discrimination. I'm assuming here that we're going to sell 2 units for $5 each, let's say to 2 different buyers, and they're going to pay the same price. The first buyer isn't going to pay 6, and the second buyer isn't going to be paying 5. They're both going to pay 5. If they both pay 5, the firm is not price discriminating. You go, well, what do you mean price discrimination? Is it legal for firms to price discriminate? Yes, it is. Airline tickets. If you buy your tickets early, you pay less. You buy your tickets late, you pay more. You can be flying on an airplane in the same area of the airplane, let's say the economy section. That's where I fly. I'm a community college teacher, so I fly. It seems like I fly with the luggage, but I actually fly in what's called the economy section. And in that section, if you talk to people, you'll see that people paid different prices for their tickets. Some people paid less, some people paid more. In fact, it's very interesting. Almost everyone paid a different price depending on when they bought the ticket. So the airline industry has a tiered pricing system where if you buy early, you pay less. If you buy later, you pay more. And therefore, different people pay what? Pay different prices for the same output. That's amazing. Get the same service, you're going the same destination. Everything related to the service is the same except the price. We are ignoring that. We are assuming every unit is sold at the same price within the interval of time we're looking at. So back to our point here, if we're going to sell 2 units, we have to lower the price of both units to 5. So in selling the second unit, we pick up 5, but look at this, we lose 1 on the first unit. Where when we sold the first unit, we sold it for 6, and we picked up 6. But when we sell the second unit, we pick up 5, but lose $1 on the first unit, which means we net what? We net 4. So what is the marginal revenue of the second unit? It's 4. Interesting. Let's keep going. If we want to sell the third unit, we have to lower the price of all 3 units to 4. Notice we could sell the first 2. If we were only selling the first 2, we could sell them for $5 each. But if we want to sell that third unit, we have to lower the price of the first 2 units each by $1. So what happens when we sell that third unit? We pick up 4, we lose 2. We net 2. We want to sell the fourth unit. To sell 4 units, we have to lower the price of all the units. Don't forget that. To sell the fourth unit, we have to lower the price of all the units to 3. When we sell that fourth unit, we pick up 3, but we lose, look at this, we lose $1 on the first unit, we lose $1 on the second unit, we lose $1 on the third unit. We pick up 3, we lose 3. That's going to be a net gain, a net revenue improvement of 0. And if you keep going, it becomes negative. What you're losing on the previous units turns out to be greater than what you're gaining on the additional unit. So this is fascinating, at least I think it is, that you could actually produce units that produce no additional revenue for the firm or actually deduct revenue from the firm. And it's going to depend on the behavior of the demand curve. And in this model, this is the price making model. For the price maker, what we see here is price is greater than MR. Now, except for the first unit. We sell the first unit for 6, price is 6, and we get marginal revenue of 6. But for every other unit, price is greater than marginal revenue. For instance, let's look at the third unit. Here's the third unit. We sell the third unit for a price of what? 4. But the third unit only brings in 2. Price is 4, marginal revenue is 2. Let's say we want to sell the fourth unit. We lower the price to 3. We get $3 on the fourth unit. However, the fourth unit doesn't add any revenue to our total revenue. Its marginal revenue is 0. So again, except for the first unit, price will be greater than marginal revenue. Now remember, price, this is very important, is an average. Price is an average. Marginal revenue, as the title would suggest, is a marginal. So these are apples and oranges. Marginal revenue is telling us how a particular unit affects our revenue. Price, on the other hand, is an average. It's what buyers pay on average for all the units. In this case, they're not equal. Now, just a reminder that if you go back to my previous lesson, the graphing exercise on pure competition, you would see that in the case of the price taker, which is a competitive firm, say a farmer, price has to equal MR. In other words, the average has to equal the marginal. But that, of course, does not always have to be true for all firms. And in fact, most firms are price makers. Now listen, I didn't say most firms are monopolies. I said most firms are price makers. In other words, most firms have some price making ability, which means most firms face a downward sloping demand curve. Some firms are price takers. Actually, relatively very few firms are price takers. If you're a price maker, price is greater than MR. If you're a price taker, price equals MR. Okay, I've already said that, so let me continue. Now, if we graph these ideas, let me show you a diagram of this, a simple diagram of this. So let me see if I can draw a straight line this morning and another straight line this morning. Not bad. And this is going to be dollars. This is going to be Q. Let me go ahead and use a straight edge. I think I'll do better with a straight edge. So let me put a straight edge in here, and oh, that's not bad. And let's put a demand, call that a demand curve. And then I want to draw a steeper function to the left. So I'm going to start up here, and let's go right there. We'll call this my marginal revenue curve. Okay? Now, let's pick an output rate. Let me say that we are right here. Say that this is Q3. So here's my point on the demand curve, and here's my point on the marginal revenue curve. And let's use the data we've been using. Let's say this is a price. This is a price of 4. So what does the price tell us? On average, we sold 3 units. On average, we sold 3 units for 4. But notice, marginal revenue is below price. Marginal revenue, in this case, is 2. So why does MR slope below the demand curve? Well, MR is not an average. It represents the revenue we generated, not on all 3 units, but the revenue we generated on the 3rd unit. Again, this is a marginal. Whereas the price point is an average. It's what we sold all the units for on average. Please, please, please make a note of this. If you don't keep that sorted out, you're going to get confused. Notice my demand curve is steep, but my MR curve is even steeper. So where my demand curve in this data is it has a negative slope of 1. It's dropping 1 to 1. Drop my price 1, sell 1 more, 1 million more, whatever. My MR curve is dropping much faster. Every time I produce an additional unit, my marginal revenue drops by 2. Look at the table. You can see that. Every time we produce one additional unit, marginal revenue drops by 2. So the marginal revenue curve is actually much steeper than the demand curve, which represents price and quantity. Okay? Very, very important stuff. All right, now we're ready to really graph the monopoly model. And let me see if I can draw a nice big picture nicely. So let's put a vertical axis, horizontal axis, as horizontal as we can make it. Dollars, Q. I'm going to draw a dotted line in the middle of this space here. What I'm going to be doing is I'm going to be giving 4 data points at a certain output rate. So let's say this output rate here is 5,000. So this is output. This is dollar amounts, and there'll be a variety of dollar variables over here. For instance, let's say the price of this product is 38. Why? Because that's what it is. Let's say that the marginal revenue on the 5,000th unit is 32. Given. Let's say the average total cost of producing 5,000 units is 27. Just making the numbers up. And let's say that the marginal cost is 21. Okay? Just making numbers up here. I'm after something. I've done this enough that I know where these numbers are going, but I want to bring an objective or two out of this. Now, let's think about this a second. Before I start drawing this, let's think about some things. Is this firm profitable? Is this firm profitable? What do you think? Well, it is. Price minus ATC times Q is going to tell us the profit or the loss. So we're selling them on average for 38. They on average what? Cost us 27. So on average we're making a profit of 11 times how many units? 5,000. That equals a total profit of 55,000. 55,000. Okay? We're profitable. Are we maximizing profits? Well, to maximize profits, MR must equal MC. They don't equal. MR is greater than MC. If MR is greater than MC, the firm is underproducing. Underproducing. Why? The firm is not produced enough to get to the point where MR equals MC. So what we should expect as a consequence of this is the firm is actually going to lower its price and increase its quantity. You say to me, Mr. Cipcic, monopolies never lower their price. That is a myth. Now, I don't have time to go through all the myths of monopoly, but there are a number of them. But listen, the goal of the monopolist is not to maximize price. The goal of the monopolist is to maximize total profit. You go, well, that's the same goal the purely competitive firm has. Exactly. We assume that all business people are equally interested in maximizing profits. In other words, this might shock you, we assume that a monopoly is no greedier than a purely competitive firm. A utility company is no more sinister than a farmer who grows soybeans. They both want to maximize profits. Now, obviously, a monopoly may have some advantages that a soybean farmer does not have. If there's a zillion soybean farmers and only one producer of electricity in our area, then the utility company is going to have some advantages that the soybean farmer doesn't have. And we'll be talking about those. Not in this lesson, but I'll be talking to you sometime about it. The point is, the goal of the monopolist is not to maximize price, but to find the price that maximizes total profit. Knowing that will change your life because it will change your grade. Okay, all right, so let's go ahead and let's draw this monopoly. And I'm going to try to use a straight edge to keep this. I did it. Yes. Okay, so that worked. There's our demand curve. And I want to also use a straight edge for the MR curve. So let me see if I can get this to. I think that's going to work. So yes. All right, there we go. So there's our MR curve. And remember, MR can be negative, so you can draw it below the axis if you like. Now, don't have time to go through all the cost principles again, but we've talked about them at length in the purely competitive video. Okay, so I'm going to just quickly sketch them again. If the last unit cost, the 5,000th unit, costs less than the average of all the units, the average has to be what? The average has to be coming down through that point, which means it's got to hit its minimum where? Somewhere to the right. Let's say right there. Now, I'm troubled that my MR curve is in that same spot. You've got a lot of things happening in this little area here, but let's assume that that point is not where MR hits the ATC curve. I don't want you thinking that it's where MR hits ATC. That's not necessarily the case. This demand curve could be further left, which means the MR curve could be further left. This demand curve could be further right, which means the MR curve could be further right. The key idea is that ATC is dropping through this point, which means it hits its min at an output rate greater than 5,000. Okay, so now we're going to draw in the MC curve. The MC curve has to go through that point. It's got to go through that point. Then it has to what? Increase at an increasing rate. So MC has to be going through the MC point because the MC point is on the MC curve. MC must cut ATC at its minimum point. And we explained this in the last video. MC must cut ATC at its minimum point. Okay, that's the rule. And it's actually a mathematical relationship. Now, where should the firm operate to maximize total profit? Well, where MC equals MR. So here's MC, here's MR. Where do they meet? They meet right here. Now I know these 2 points look very, very close, but they're really not the same points. The minimum point of the ATC curve and the point where MC equals MR are not necessarily the same points. Can they be the same points? Yes. Are they necessarily the same points? No. And my diagram in that respect is a little bit confusing. Now, let's read from the demand curve down through that point. Notice where MR equals MC, that's going to be the quantity where the firm should operate. So this firm needs to produce more. But this firm is a price maker. How is it going to induce buyers to buy more? It has to lower its price. You go, monopolies never lower their price. Myth. Monopolies are happy to lower their price if that means greater profits. Okay? There's a lot of mythology out there. You're unlearning some of this. So we would expect the monopoly to lower its price and raise its output rate to maximize profits. And we can actually draw the profit box by finding the point on the ATC curve. I almost hate to even identify it. We've got so much going on here. But we have to find the point on the ATC curve that corresponds with QM, and then here's our total profit box. I'm going to draw one again, and I'll try to do a little better job of not getting everything in the same place. So the moral of the story is this monopoly should lower its prices, increase its output rate to maximize profits. We could actually determine QM and PM if we had more data, if we actually knew the parameters for these functions, if we knew the actual formula for demand, the actual formula for MR, the actual formula for ATC and MC, we could easily identify these optimal points. Okay, let's do one more just for the fun of it. Since you've already listened this long, let's give you a little more practice, and then we'll turn you loose to work on your own dime and time to draw these. Let's face it, all you're learning is that I can do it. Okay, you're learning that I can do it. You have to learn that you can do it, and the way you learn you can do it is by doing it. Okay, now let's put in our dotted line here, and let's say we're talking about 20,000 units, and let's say the price is up here. Now let me make that MC. Let's do a different setup. Let's say the MC is 40. Let's say the price is 30. Let's say ATC is 35. No, 25, excuse me. 25. And let's say that MR is 15. Let me get out my fancy smancy editing tool and show you that I can actually erase with this. What do you think? What do you think? You have never seen me erase before, have you? Mainly because I make so few errors. But in times past, when I've made errors, I haven't bothered to erase. I just want you to know that I have an erasing tool and I know how to use it. And there's other features I haven't. Keep watching these videos, you're going to be amazed. Okay, this is 25. Okay, there we go. All right, now we got to draw our functions in. Let me go with cranberry or something. Maroon. Boy, that's a blast from the past. My dad owned, back in the late 60s, a maroon Chevy Caprice. Where were you in 68? I was 11. Okay, there's the demand curve. Why did I put the demand curve there? Because I was talking about my dad's Caprice and I wasn't paying attention. That's not where the demand curve goes. There is my more powerful erasing tool. It erases everything under the sun. Let's try this again. If you screw up, don't fret. Try again. So our demand curve goes through the price point. Let's be careful to put the demand curve through the price point. Why is the price point on the demand curve? Because the demand curve is the relationship between price and quantity. So make sure you put the demand curve through the price point. Where does the MR curve go? The MR curve is related to the demand curve. I just proved that to you earlier. And they're related, but they're not parallel. So we are going to want to put an MR curve through the MR point. Notice it's even steeper. And I said it would be steeper because it has a greater slope. Okay, so make sure your MR curve, come alive, pen tool, make sure your MR curve is through the MR point, only because your MR point is on the demand curve. Now MC, the cost of the last unit, is greater than the average cost of all the units. So we need an average total cost curve that has hit its min and is heading up. Then we need MC to cut the minimum point of the ATC and then continue up through the point specified for it. Something like that. So MC has to meet two specs here. First of all, it's increasing at an increasing rate. That looks kind of like a straight line, but I'm going to pass myself on that one. And then MC has to cut ATC at its minimum point, and MC has to cut this point, which has been specified for it. Again, MC must go through the MC point only because the MC point is a point off the MC curve. It's that simple. Now, where should this firm operate to maximize total profits? Well, let's find where MC equals MR. That's way up here. This firm should actually produce less. Why? Well, MC is greater than MR. The last unit costs 40, the last unit only brought in 15. If the last unit costs 40 and the last unit only brought in revenue of 15, we shouldn't have made it. Are we profitable at 20,000? Yes. Price is greater than ATC. On average, we sell them for what? On average, we sell them, these units, for 30. On average, they cost us 25. On average, they profit us 5. 5 times what? 20,000 is what? That should actually be the variable. 5 times 20,000 is what? It's 100,000. So the firm is quite profitable at 20,000 units. Is it maximizing total profits? Can't be. Why? We know because we can look at the last unit and see that we've made a unit that cost us more than it benefits us. MC is greater than MR. We've produced a unit that cost us more than it benefits us. We are overproducing. We need to raise our price to reduce our output rate. So we're going to reduce our output rate from 20,000 to something, and in how are we going to sell fewer units? We are going to raise our price. So PM, the profit maximizing price, is going to be somewhere above 30. QM, the profit maximizing quantity, will be somewhere below 20. Notice PM is not the maximum price. The maximum price could be way up here somewhere. But the goal of the firm is not to charge the maximum price. The goal of the firm is to charge the profit maximizing price. And the profit maximizing price is not the maximum price. I double dog dare you to say that to someone today and see what happens to their face.